Hello everybody and welcome back. Root Beer here, and I've got question B2 from the 2013 open paper all ready to be looked at. There is a unique triplet of positive integers, a, b, c, so that a is less than or equal to b is less than or equal to c, and 25 over 84 is equal to 1 over a plus 1 over ab plus 1 over abc. And we are being asked to determine a plus b plus c, which is good, because I'm not entirely sure, given the information we're given, that we could get a, b, and c, but we might be able to manipulate this expression to give us an a plus b plus c. We'll see. But I think we might be able to at least do that. Okay, so I have to remember positive integers. Other than that, what have we got? Okay, well, I'm not the biggest fan of fractions on their own, so what I'm going to do is I am going to put them all over the same common denominator. And then 25abc is going to be 84bc plus 84c plus 84. Alright, so, nice expression. I enjoy it, but what can we say? Well, actually, I think we could say a bit. I've gone a little too far. Let's say 84 here is BC plus C plus 1. So in order for this to work out, if A, B, and C are all integers, then this expression and this expression, these are integers. So I've got two products of integers, which means I can start to look at their factors. Now, we've got 5 squared over here. 5 squared ABC is equal to 84. Now 84 is going to be 2 squared and then 21, so 3 to the 1, 7 to the 1. BC plus C plus 1. You'll notice there are no factors of 5 here, so we've got to have 2 factors of 5 here. And there's no factors of 2 or 3 or 7 here, so A times B times C has to be 84 times k. So there's got to be some 2s, some 3s, some 7s. Okay, so 2 squared, 3 to the 1, 7 to the 1. Okay. All right. So where can we go from here? Well, I'm sort of inclined to just try and take a guess and say, well, why don't we let A be 3, B be 4, and C be 7? And then we don't have to deal with this pesky K. Can we make it work there? So B times C is 28, plus another C. That's not going to work out, unfortunately. Now BC plus C plus 1. Is there another way I can write this? I think it's B plus 1, C plus 1 minus B, but that's not really any more helpful, I think. Maybe it's slightly faster for computing this expression here, but so be it. Sorry, comparing to 25. Now, there's no reason for me to be thinking that ABC has to be exactly 84. I'm just trying to make a very simple guess, because if I can just work it out with a guess, I can move on. It's a B question. I don't have to be writing everything up nice and neat and perfect. So what I've gathered from this is B and C are too close together, and C's kind of too big almost. So what else could we try? I do have the right order here. Yeah, C and B are the bigger ones. So maybe BC is just too big, and I do need something. So maybe we try 50. Maybe try K equals 2. And so we get 2 to the 3, a 3 to the 1, and a 7 to the 1. And I want BC plus C plus 1 to be 50. Maybe we try that. So maybe A is 3, B is 7, and C is 8. Well, no, 7 and 8 is going to be 56. Way too big. Way too big. But we could try something else. Maybe A is 4, B is 6, C is 7. And then, oh yeah, that'll do it. BC will be 42, plus 7, plus 1, so that'll be 50. And yeah, that works out. So 24 and 7, 12 and 7, yeah. So there we go. And then A plus B plus C is 17. Now, some of you out there might be not so satisfied by what we've got here. You might say, well, isn't there a more exact way to go about doing this? And for the life of me, I can't think of one off the top of my head. If you've got one, I would love to hear about it down below in the description. I'd even give it a like, because I can't think of an exact methodical way to go about doing this. The restriction here about positive integers really, to me, says play around with some of the numbers. Try something out. Okay? The reason being, positive integers aren't the easiest thing to work with. We also have way more variables than equations. So it's very hard to isolate for C or for B or for A. And I think it's going to eventually come down to guess and check. Now, you could do other things, like you might be able to find a way to restrict it and say, well, you know, A has to be in this range or something to that effect. But I think the reasoning that I gave while I was doing the question sort of made it clear how I was going about it. I tried just the obvious 84 and 84, and then I realized, well, the BC combination, it's almost too big, so I tried something a bit smaller. Now, I just want to make sure there is a unique triplet of positive integers, so I've got my triplet of positive integers. They're telling me it's unique. I don't have to find all possible values of A plus B plus C. We're done. I just happen to have stumbled upon it. So, that was B2, right? Yeah, that was B2. So up next, we're going to look at B3 on our 2013 paper. Until then, have a wonderful day.